Welcome. Today we're going to talk about adding and subtracting fractions with like denominators. And we're also going to do the least common denominator. So we're going to find the least common denominator. Now in my last recording I foolishly said that adding and subtracting is hard. And I wasn't wrong about that, but we're not going to do the hard stuff today. We're going to get ready to do the hard stuff. The hard stuff is that when you're adding and subtracting fractions, the denominators have to be exactly the same. Exactly the same. And at the end of this recording, I'm going to show you how to find the same, exactly the same denominators. But for now, all we're going to say is, well, if we've succeeded in getting the denominators exactly the same, then all we have to do is add or subtract the numerators. And that's what we'll do. So here, the denominators are exactly the same. So we'll take the numerators and do the operation here. It's subtraction. So 9 minus 5 is 4. And then we'll keep the denominator exactly, for the answer is exactly the same as the denominator for the numbers we were adding or subtracting. And that's the rule. The denominators have to be exactly the same because they're going to be exactly the same in the answer also. 4/13. So 9/13 minus 5/13 is 4/13. I like to use my little apples and oranges thing. 9 apples minus 5 apples is 4 apples. So the denominator is just what kind of thing we're talking about. We're talking about 13ths. So how many 13ths do we have? If I have 9 of them and I subtract 5 of them, I have 4 left. All right, let's do the next one. 3 over 10y plus 2 over 10y. Notice that the denominators are the same. So we are then allowed to just add the numerators. So 3 plus 2 is 5, and then we keep the denominator exactly the same, 10y. Biggest mistake students make here is thinking, well, we've got to do something with those 10y and 10y. It can't just be 10y plus 10y is 10y. So the big mistake everybody makes is saying, well, maybe it's 20y or 20y squared or something like that. But the idea is that this 10y and this 10y says what type of thing, this is what type of thing we're adding. We're adding the same type of thing, and so we have more of that same type of thing. We had 3 somethings plus 2 other somethings, that gives us a total of 5 of the same kind of somethings. Okay, so that is how you do addition. Now, final little bit here that shows up in this problem is the idea that addition changes the factors of the numerator, right? Remember, factors are what you multiply to get something. But when we add things together, like 3 plus 2, that suddenly changes what the number is on top, and so now the factors are different, which means that maybe the new fraction can be reduced, and it can. This is 5 over 10y, which is 5 times 1, over 5 times 2 times y, and of course the 5's cancel, and we're left with 1 over 2y. So it's really important whenever you do addition and subtraction to check to see if your answer can be reduced, which is very different from multiplication and division. If we're using the factoring method to multiply and divide fractions, then we know that our final answer is reduced already. We don't have to do anything more. Okay, let's just do a couple more examples. Hit pause and try these on your own. The denominators are the same. We add the numerators or subtract as whatever it tells us. So 15b plus 7b is 22b. And keep the denominator exactly the same. Then we say, well, wait a second, 22b is 2 times 11 times b, and 16 is 2 times 8 times b. Notice I didn't factor 8 out because I know that 11 is prime and there's only 1 2 in the numerator, 2 times 11, and there's 1 2 in the denominator, 2 times 8. I could write that 8 as 2 times 2 times 2, but there's no other 2 to cancel with it, so I saved myself that trouble. And oh, I made a mistake. Did you see what I did there? I just made up a b in there. 2 times 8 is 16. There's no b. So it's 11b over 8 is the final answer. I was able to add the numerators together because the denominators were exactly the same, and then that answer was a fraction that could be reduced, which is a completely different process, so I don't have to think about adding anymore. I'm just thinking about reducing fractions. Okay, let's do one last one. Denominators are all the same, therefore I can do the operations here, which are all subtraction. 9 minus 7. 9 minus 7 is 2, and then minus 10. 2 minus 10 is negative 8. So I have to remember our addition rules for integers, adding and subtracting integers. Then the denominator is exactly the same, 12. Finally, I'll take a look at this and see if I can factor negative 8 and 12 so that we have common factors. Negative 8 is negative 2 times 4, and 12 is 3 times 4. I could break those 4's down into 2 times 2 if I wanted to, but once I get them into factors that are the same, I can just cross them off. So the 4's cancel, and I'm left with my final answer of negative 2/3. But again, notice that once I added and subtracted the numerators, kept my common denominator, then I stopped thinking about adding and subtracting, and I started thinking about reducing, which is a different process. So one of the things that makes math hard is that you have to think of lots of different things, but you don't ever have to think of all those things at once, as long as you are willing to kind of switch hats. You need to just say, okay, let's follow all the rules for adding and subtracting, and then we'll stop thinking about that and we'll start thinking about the rules for reducing fractions, which are different, and we'll do that for a while and then we'll be done. Okay, last bit here. Find the LCD of each pair of fractions. And so for these questions, I'm not even asking you to, we're not asking you to add the fractions together or do anything. All we're asking you to do is to look at the denominators, 12 and 20, and say, what's the LCD? Well, first of all, what does LCD mean? LCD means the lowest common denominator. And this is asking what's the smallest denominator you can get that has both 12 in it and 20 in it. Okay, so let me show you the process I go through. I take the 12 and I write out its factors. That's 2 times 6, which is 2 times 3. So I literally think that. 20 is 2 times 10, which is 2 times 5. Then I say, what's the greatest common factor between 12 and 20? And it's going to be 2 and 2. So 2 times 2 is the GCF. GCF, the greatest common factor is 4. Then the LCD is going to be the GCF, 4, times all the factors that we didn't use, 3 and 5. So the LCD, the lowest common denominator, is the numbers, all the numbers that are in each, all the factors that are in each denominator. So 20 has a 4, 2 times 2, and a 5. And 12 has a 4, 2 times 2, and a 3. So my LCD has a 4 and a 5 and a 3 in it. But notice, because the 20 and the 12 both had a 4 in them, I didn't have to use the 4 twice because that one was a repeat. So I don't have to use any of my repeat factors. 4 times 3 times 5 is 100, is 100, is 60. Now, let me show you another interesting fact about LCDs. 60 divided by 12 is 5. And 60 divided by 20 is 3. The LCD is the number that can be divided evenly by both other numbers, both other denominators. That is how LCDs work. So let's go through the steps. We factor both the numerators and denominators. We find the factors that are the same and we write those down. That's our GCF. And then we find all the factors that didn't get used, that were not the same, and we write those down in a big old line, and then we multiply them together, and we get our LCD. That's a bit of a complicated process. If you can spot the LCD without doing that process, then good on you. But most of the time I have to think about it this way. I don't always have to do prime factors, maybe, but I usually have to think about it this way. Okay, let's do one here, 24 and 45. 24 is 2 times 12, which is 2 times 6, which is 2 times 3. 45 is, well, let's see, that's 9 times 5, so that's 3 times 3 times 5. And notice the only thing they have in common is a single 3, right? 45 has 2 3's in it. 24 only has 1 3 in it. So the LCD is going to have that 3, and then it's going to have 2 times 2 times 2, and then the 3 times 5, and that will be it. Now, that's a lot of numbers to multiply together. We can think about how we're going to do that. Maybe I'll do 3 times 2 is 6, times 2 is 12, times 2 is 24, and 3 times 5 is 15. And then I'll have to do some long division here, 24 times 15. So my LCD is 360. Turned out my LCD is really big. Now, let me tell you why we care about the LCD. Here's why. When we add fractions together, remember, when we're adding fractions together, we can't add them until the denominator is the same. Some people have this idea that if we just multiply the denominators together, 45 times 24 and 45 times 24, then we'll get the same denominators. And that's true. We will get the same denominators. But that number will be bigger than it needs to be. I think it's going to be 1,080 or something like that. So that number will be way bigger than it needs to be, which means that we're going to be doing a bunch of math that's more than we need to do. So the LCD saves us a lot of time, because when we add these together, in order to multiply the denominators by something, I multiply that 24 by 45, I have to multiply the numerator by the same thing, 45, and this numerator has to be multiplied by 24 because I multiplied the denominator by 24. Okay, we'll talk about all this next time, but you don't want to do a lot of big math here. You want to make that math as small as possible. And so the least common denominator is very valuable to us, because it means that we're not having to do a whole lot of really hard, big math. And we're doing the smallest amount of math we could possibly do to get these fractions in shape so that we can add them together. Okay, so that's coming down the road. Right now, all we're looking for is the LCD. It's not that difficult. Give it a try and make sure and check your answers.